Okay, next video, solve the following. Now notice, even though it's a funky square, I've got 4x minus 1 quantity squared. We can note that this is a square term and numbers. Just like the previous guy, only x squared and numbers. X squared and numbers. Here, a square term. It's a fancy square term and numbers. That is good for the square root method. So my first step will be to get whatever's squared alone. So that's not going to be too bad. So divide both sides by 2. And so I get 4x minus 1 quantity squared equals negative 9. And then once my square is alone, I can take the square root of both sides as long as I remember to include that plus or minus. You've got to include the plus or minus whenever you're solving equations and you take the square root or even root of both sides, you include the plus or minus. And the square root and the square cancel. So I get 4x minus 1. And then simplify here, plus 3i. Now we need to finish solving. And so I've got to get the x alone. So I will move that 1 to the other side. So I get 1 plus or minus 3i. And then I can divide by 4. And so I get x equals 1 plus or minus 3i divided by 4. Now, if this is a small class where I'm actually doing my own grading, there is a perfectly fine answer for me. But if the computer is grading, for the computer, it wants standard form. A plus bi or a minus bi. So to get that, 1 plus or minus 3i over 4 becomes 1/4 plus or minus 3i over 4. And you think that'd be good enough, but that's not good enough for the computer? It wants that I completely and totally on the end. So it would want 1/4 plus or minus 3i over 3/4 I, or very specifically 1/4 plus 3/4 I, and 1/4 minus 3/4 I. And so that's what you'd have to type into the computer. So for the computer, you're going to need to do that. If only I am looking at it, I am perfectly fine with that answer there. But this one demonstrates why we did the work with the complex imaginary numbers, that now that we have quadratic equations, sometimes complex numbers will occur. Now this one we can't check by graphing. The only way you could check this one is the old-fashioned way of taking my answers, plugging them back into the original equation and seeing if it works. You can't, that's the only way you can fundamentally check it. But we can check to see that we're in the right ballpark as far as my answers involve complex numbers, that my answers involve imaginary numbers. That I can check. So thinking about checking and trying to do the same things that we've done before, I've got checking my equation, so I'm going to set it equal to 0 just like I always do. Type in, then press y equals and type it in. And here there's more stuff here that I have to futz around with the window. I'm not going to really go into great deal with it. But the problem with that Zoom 6, it says, note here, however, Zoom 6 did not produce an adequate graph, so we need to change the window. And a lot of times you're just messing around with those numbers till you get a picture. So I messed around with it till I eventually got a picture that looked like that. And it has no x-intercepts. And there should be no x-intercepts because the solution is a complex imaginary number. If your answers come out to be imaginary, that means there will not be x-intercepts. X-intercepts correspond to real solutions, to things without eyes. So the graphing approach checking does have its drawbacks, that it won't check for 100% accuracy because our answers involve the imaginary unit. But at least it does tell me, hey, no x-intercepts, the answers must be imaginary. So the graphing way of checking does have its drawbacks. So that was the square root method. Going to the quadratic formula. The quadratic formula, like completing the square, will always work. Some students try to exclusively use the quadratic formula for all quadratics. While this is possible, it's not a good idea, as the quadratic formula is more cumbersome than factoring the square root methods. So if an equation can be solved using either factoring or the square root method, it's better to use one of those. You should get the same answer regardless of the method you use, but it's just that factoring and square root will be faster. And so if those work, they're just a little easier. Okay, so there's the quadratic formula. If ax squared plus bx plus c equals 0, a not equal to 0, then x equals negative b plus or minus the square root of the quantity 4b squared minus 4ac all over 2a. Many high school teachers will teach students to sing a song for that. Yeah, I'm not going to teach you a song. You don't want to hear me sing, trust me. You must memorize that. And you need to keep it memorized until you're finished helping your own children through their algebra in, 20 years from now, 30 years from now, when you're helping your own children through algebra. You need to keep that memorized until then. The important thing here, one important thing, equal to 0. The quadratic formula is only valid if the equation is equal to 0. So my steps here. If the equation contains fractions, clear the fractions. You don't want to use that formula and put fractional values in there. Clear the fractions. 2, if necessary, rewrite the form to the form ax squared plus bx plus c equals 0. That is, set it equal to 0. Identify a, b, and c and substitute in the formula. And then 4, simplify. Work inside the radical first. Then simplify the radical if possible. Multiply out the denominator. B, if it was possible to simplify the radical, simplify the entire fraction if possible. The entire fraction will simplify only if all terms have a common factor. If all terms have a common factor, divide the terms by this factor. And then 5, good habit, check. So let's do a problem. Okay, 3 halves x squared minus 2x equals 0. First thing I'm going to do is clear the fraction. You have an equation with the fraction, clear the fraction. I'm going to multiply all terms by 2. So 2, 2, 2. The 2's cancel. So I get 3x squared minus 4x equals negative 4. Then I look to see what I have. That square makes it a quadratic. Now let's pretend that we are not learning the quadratic formula, that we are just going to choose whatever method works best. Choose a method. Not the square root method. Because of the x term. Both times we did the square root method, we said, oh, gee, the square root method's going to be good because I just have square and numbers. That's not what I have here, just square and numbers. So it's not going to be the square root. So it will be either factoring or quadratic formula. Both of those I have to set equal to 0. Now you're not writing this down. This is just your thought process. So I now know that my next step is to set it equal to 0. And then I look at it for a little while. Can I factor this? And if you're not good at factoring, don't look at it much more than about 10 seconds. But it's not easy to factor. So quadratic formula. And like I said, you're not writing any of this down. This is just your thought process. So quadratic formula. A is 3, B is -4, C is 4. And so x equals negative b plus or minus b squared minus 4ac all over 2a. And so I plug in there -4 plus or minus -4 squared minus 4 times 3 times 4 all over 2 times 3. And now we just start working it out. Double negative makes that positive. Then that's going to be 16 minus 48 all over 6. And so that's going to be 4 plus or minus the square root of -32 over 6. And notice I have not canceled anything because I can't yet. So that's 4 plus or minus I. The -32 gives me the I. Then 32 is 16 times 2, which gives me 4 plus or minus 4i square root of 2 over 6. And now I can cancel. Now everybody is divisible by 2. And so I'm going to get 2 plus or minus 2i square root of 2 all over 3. That's a perfectly good and happy answer for me. For the computer, that would be 2/3 plus or minus 2 square root of 2 over 3i. And again, you have to type, for the computer, you have to type it out twice because there isn't a plus or minus. And there we solved it using the quadratic formula. So, you know, it is just a formula, you just have to use it. Now, a comment here. A lot of you are going to do your arithmetic on your calculator, and that's fine. But right here, where I wrote -4 quantity squared, those parentheses were absolutely necessary. Without the parentheses, it's not going to square it the way you anticipate it. The only way to make your calculator square the number -4 is to put that number in parentheses. So whenever you're raising a negative number to an exponent and you want your calculator to do it correctly, you've got to put it in parentheses. You don't put it in parentheses, it will be wrong. And that's where we will end this video.